I'm Professor Neerav Mehta from LG Institute of Technology and Engineering. So today we are going to discuss about subject called automobile system design, in which today's topic is to discuss and to learn about lining material and heat dissipation during the braking. So before selecting this brake lining material, we should learn about what is the mechanism of braking and how this brake works. So the function of brake is to regulate and absorb power and velocity of a vehicle. So by means of friction and by means of force, it absorbs this power as well as velocity of a moving vehicle. And this excessive energy and force will convert it into heat, as well as in some cases it could be converted into shock. So here we have to design material which can adapt to this heat as well as to some amount of shock. So while considering this brake lining material, because this brake lining material very essential because of it is the material which directly comes into contact with that moving element which is rotating and which should be stopped. So here our concern is to select material depending on it should be absorb whole amount of energy as well as velocity at the same time. It shouldn't be faded that much easily that it could directly affect the life of our brake. So here we will discuss about different properties and different types of properties which it should require by selecting this material of a brake lining. So first of all, it should have high coefficient friction to develop that connection or to develop that braking effect, because ultimately a brake has to break the torque of a rotating element. What is the function of the brake function of brake is to absorb the velocity and power by means of breaking the torque of that rotating element. And how it will break the torque of rotating element? By means of friction. So our material should have high friction with minimum fading. So it should provide high friction between that rotating element and our element which is stopping or which is stopping our moving element, which should have higher friction, which which should have lesser amount of fading. Clear? In other words, you can also say that friction should remain constant all over the life and over the surface, even if its temperature changes. Means it shouldn't show any kind of significant change with respect to change in temperature. So here material has two properties, should have two properties. One is it should have high coefficient of friction but with minimum fading in each and every condition, whether it could be a high temperature, low temperature, raining or anything. It should provide minimum fading. Second point here we will discuss as it should have higher heat resistance and low wear rate. What is this heat resistance? Means it shouldn't be prone to very heated, or you can say it shouldn't be change its property if the heat increases. At the same time, it shouldn't get weird out. It shouldn't get weird out at any condition, at any operating condition or any atmospheric condition. So our brake should have higher heat resistance, mean it shouldn't be get into or absorb any excessive amount of heat while working as well as from atmosphere. At the same time, it shouldn't show any kind of wear according to its working condition, at the same time to the atmospheric condition. Fourth point, it should have high heat dissipation capacity, because heat is unavoidable in this friction mechanism, because ultimately friction brings heat in our scenario, and ultimately this heat is generated just because of higher amount of friction. This higher amount of friction will ultimately leads to excessive amount of heat generation, and this heat should be dissipated with the help of natural heat conduction convection. We have to design our system, or we have to select that material that it should have high dissipation of heating capacity. Clear? So it should dissipate heat as soon as it get heated due to this friction motion. Clear? Then it should have low coefficient of thermal expansion. Ultimately, it shouldn't be changing its property as well as its shape and size. So, as you know that when heated, any material which is heated up, it should tends to increase its size. So, this shouldn't, this material, the selection of the sliding material, there shouldn't be increases size by means of any kind of heat connected with that. Clear? And then it should have adequate mechanical strength. Means it should have mechanical strength. It shouldn't be tear apart. It shouldn't be compressed. It shouldn't be torn or anything while working condition or so. Ultimately it should have higher efficiency, which is toughness, as well as in some cases it should have higher ductility also. Clear? So these are the mechanical properties of a brick. And then it should not be affected by moisture and oil, because as we know that our brake always and constantly work under the condition which could be high heat or high raining condition, or ultimately the oil leakage or oil between our two surfaces. So it shouldn't have any chemical reaction regarding to this moisture as well as oil. So it shouldn't be affected by this kind of moisture as well as oil. So we have in this points, by this point we have discussed about different kind of material properties for our selecting of our brake material. Once again, let's repeat this point. First point is it should have higher friction, but also it shouldn't be have higher feeding ratio. Means it should have low feeding ratio. Ultimately, it should remain constant over the period of the time. Clear? And over the period of the surface at the same time. It should have low wear rate. Clear? At the same time, it should have high heat resistance, and it should have high, even this heat dissipation capacity should be high. Clear? It should show low thermal expansion. It should be changing its shape and size according to temperature changes. Clear? It should have adequate mechanical strength, toughness, ductility, wear strength, faded strength, anything. Clear? And it shouldn't be affected by moisture and oil. That's also a chemical reaction which comes under the case. Let's move on to heat to be dissipated by breaking. There are several materials like leather fiber and wood facing. The maximum heat, the leather fiber and this wood facing could be in a working condition, that is 65 to 70. If the temperature the temperature goes above to 65 to 70 degree, it will be directly affecting to the working and efficiency of our braking. So, for if we are using a leather or a fiber or a wood as a facing material or as a braking material, we should be making sure that the temperature shouldn't be exceeded to the 65 to 70 degree of the Celsius. Another material is a very well-known material, which is asbestos, as well as sometimes we can also use those woven metal material or metal surfaces, like wire of metal is woven with the asbestos. So at that combination, it can attain maximum, or it can work properly or efficiently until the temperature 90 to 105 degrees centigrade. If the temperature increases beyond this limit, it will ultimately deteriorate the efficiency as well as shape and size of our braking material, which is woven with the asbestos and metal. Then, for automobile brake with asbestos block lining, where we have used those blocks of asbestos, it can have a higher amount of that maximum temperature, and they facilitate us to work in any condition. But the limit for that is 180 to 225 degrees. So ultimately, we can work with this asbestos material, which have 180 to 225 degrees Celsius, and ultimately, they are more feasible compared to any other braking system. Here, the equation I have put is about heat generated. Now, let's discuss about mechanism of this generation of heat, how this heat is generated, and what is the behind working for this heat. So ultimately, what we are doing is, in this case, we are converting our mechanical work into heat by means of applying frictional force on our moving material. So here you can see energy, which is in terms of heat generated. It is directly shown as mu Rn into velocity v, where Rn is normal force and velocity v is velocity of our braking drum, or you can say rotating element. Combination of velocity and force always gives us work upon time. Clear? Because force into distance upon time. Velocity is nothing but distance upon time. uh, Rn is represented by force. So it is ultimately becomes this equation. Here you can see the equation, mu Rn into V, where Rn is nothing but the V is velocity. It is represented by displacement upon time, and force into displacement is nothing but work. And this work is multiplied by friction. So ultimately, this friction, or you can say mu, is making this frictional work or work absorbed by frictional force, and that is converted into something and which is called our heat dissipation or heat generation. How it works and how the mechanical works mechanism works. So this mechanism works with the help of pressurizing our shoes or pressurizing our disc brake with the help of external pressure system, or by means of mechanical braking or by means of hydraulic braking. So ultimately it is nothing but force. Here force Rn is nothing but pressure into projected area under the brake. Clear? So ultimately our equation becomes coefficient of friction into pressure into projected area, and V, which is velocity of rotating element. So what we are having here is we are having this frictional force which converting our mechanical work into heat, or you can say heat generate due to that absorbing of that mechanical work with the help of frictional material. So that's why this work is nothing but the work lost due to friction. Clear? We are opt to do or opt to lose this work to stop our vehicle. Ultimately our vehicle is stopped by this resisting motion which is generated due to, or resisting force which is generated due to pressure applied with the help of a mechanical external system or a hydraulic external system. So ultimately this is how the mechanism of heat generation occurs in our braking system. I hope you got each and every point which we have discussed today. Clear? For this, the reference for this particular topic, it is from Machine Design by R.S. Kurmian, but also you can find this reference in Auto Design by R.B. Gupta. This particular question, once in a while, or you can say each and every time, GTU have been asked for even 4 marks as well as in some cases 7 marks. So this is your 4 marks or 7 marks question. Once again, let me discuss about this heat dissipation by work. So in this case, work is to be converted into the heat, and heat ultimately generated which is absorbed by means of a natural phenomenon, or you can apply external cooling system. I hope you got this particular video session very well. If you have any doubt or any problem regarding to this particular video, you can directly ask me or contact me. In next video we will discuss about how this braking system work and how the vehicle's braking will work. There are 4 layers by designing this braking system. One is to design or to find out the stopping distance by applying braking on our vehicle. Second one is to design element, like if it is a disc brake or if it is a shoe brake or a drum brake. Clear? And then to design a system which is a hydraulic system or a mechanical system of our braking system. So in next video session we will discuss about minimum stopping distance for our brakes. Clear? Thank you. Thank you so much. I'm stopping here.